Okay, welcome to Payconiq. I'm now going to first briefly tell you about the company. So in this time, you can all download the app and check it out a bit. Well, we are Payconiq is a new payment solution. So with Payconiq, you can pay online in the web shop. You can pay in the store by scanning a QR code. You can also make a transfer to your friends by selecting one from the contact list and initiating a direct transfer. So this is a bit how the app works. I mean, this is the main flow. With our home screen is a QR scanner. Then you scan it and you edit some settings and then you pay it. And then, of course, there are some extra features. I'm showing it because today I'm going to speak about the architecture of this app. So yeah, your wallet is your smartphone, yay. And the company grows. So we are now, I think, more than 100 people of 35 different nationalities. And our common goal is to become the most wanted payment solution in Europe. And yeah, we will get there, I think. And now about the Payconiq clean architecture. So our goal with this architecture was to make it awesome and to also not have any bugs because no one likes to fix them. The main blocks of the architecture are very simple. So there is a view. Well, there is always a view, I think, in any architecture for iOS. And then there is an interactor that is a business logic. And then there is a scene between them that wires up view and the interactor. And then all this together is sort of one screen. So usually this is how it actually happens in the app. When you see any screen like, let's say, contacts list or, I don't know, home scanner, there is usually some view, scene, and interactor in it. Now a bit more details. So first, the view. The view is really a standalone component. It just provides UI. Unlike maybe Viper, it doesn't have any references to presenter or to the interactor. It really doesn't know anything about anyone else in this architecture. It's just a UI view controller with maybe some themes, screen sizes, layouts, animations. Now the interactor is, on the contrary, is a business logic. And I will now show some code to explain it in more details. But yeah, it has a business logic, it handles errors, and it is designed to be easily testable. So, and then again, unlike Viper, our interactors are purely functional reactive components. And this is, well, I don't know if you can see it. I cannot make it bigger, so I hope you can see it. But this is this is a sample code. It's like very, very simplified, but there are blocks here that are present in every our interactor. So there is always some input, and because, as I said, they're purely reactive components, our inputs and outputs are signals. So interactor is basically just a bunch of input signals and then output signals. So there are always some input signals. There are always some output signals. I will come back to them now. And then there is usually a big init method that binds input signals to some transformations and then to some output signals. So about outputs, we use Reactive Kit framework. So I guess if we would use another framework, it would be called differently. But in Reactive Kit framework, there are safe signals, so signals that cannot fail. And all outputs of all interactors are safe signals. The reason is that if something bad happens, a server call fails or there is a parsing error, the view shouldn't be the one handling this stuff. So the view doesn't really know about network calls and JSON parsing. So the interactor handles it. The interactor generates, let's say, error message or something. And then this error message is passed to the view. So all the view cares about is that if it gets error message, it should show error message. If it gets the list of contacts, it will show the list of contacts. So yeah, the next and this structure also makes interactors easy to test because in your test, you basically describe this contract that we expect from the interactor. So if you if you just take an interactor and then you mock, let's say, network data, network layer, then you pass some test input, and then you expect some test output. And then for the rest, you can refactor it as you like. So it is very flexible when it comes to refactoring of the interactors. And the interactor, again, was a standalone component that knows nothing about the view. It didn't have any protocols that would be related to the view or presenter. And then finally, there is a scene. The scene just binds the signals, the events that we get from the view to the input signals of the interactor, and then it binds the output signals of the interactor to the labels or, I don't know, table views. This is some code sample of the scene. We even make scenes extensions of the interactor to have less boilerplate code. And yeah, in the create, usually just a scene just means that there is a create scene method in the extension. So we create a view controller there, and then there is some binding. So in this case, if user presses load button, then load contacts will be called. And then if there is an error message, it will be displayed in an error label text. So yeah, next the scenes, they could have also called other scenes. So the navigation logic could have been in the scenes, but we put it separately. We put it in the coordinator class. So if you think of every scene as a separate screen, then coordinator is responsible for the navigation between screens. So in this example with the contacts list, this could be, I don't know, contacts list, contact details, and add contacts screen, and then coordinators are responsible for presenting them. Another thing coordinator does in the app is it holds the state. So all our interactors are stateless, meaning, well, usually an interactor just has an input signal, then it loads some data from the backend, then it does something with this data, and then it returns it back to the scene or to be displayed in the view. And interactors do not have any state. Coordinator has. So coordinator is the class that knows that, for example, tutorial was shown or not shown yet to the user. Coordinator is the class that knows at what step in the onboarding process you currently are and what step should be presented next. So that was a bit of the architecture. Is it a Viper? Well, it is. I mean, there is a view, interactor, even the name is taken from Viper. But the functions of scene and presenter are a bit different. And also we use, we have this interactor and the scene as a completely functional reactive components. So this is different from the Viper. The benefits of this architecture is that there is less global state. As I said, it's only in the interactor, so it's easier to test, and it's also easier to maintain. It is very flexible because views and interactors are really detached from another, so you can really easy reuse the view or the interactor in another module of your app. And then testability. Well, we don't really test views except for maybe some end-to-end tests. We do test all the input-output signals in the interactors. We don't test the scenes, but then scenes don't really have the logic. Scene is just binding, so I think it's not really even needed to test the scene. Now, once we have this architecture, we want to make it difficult to break. And to use it, to achieve it, we use dependency injection. We use functional reactive programming, and we also use the framework-oriented design. And how do we do it? So we have, let's say, some common framework that contains maybe string utils. And then views, they only know about this framework. So views don't know, for example, about the model framework. And, but maybe data provider framework knows about the model and the common, but doesn't know about the views. And interactors, they are also a separate framework that doesn't know about the views. Now, scenes are in a separate framework as interactors. So even though we use scenes as extensions on the interactors, we cannot access any private or internal properties of the interactor in the scene. So when we write tests for the interactors, we are sure that it's enough to only test public incoming and outgoing signals. We don't need to care about what's internal in there. And even if you are as a developer make a mistake and try to access some model class from the view or some view from the interactor, compiler just won't let you do that. And it really works. It's convenient. The downside is that build time is increasing a lot, especially if you make change in some of the basic frameworks that other frameworks use. We had to adjust this system a bit because this idea of having one view scene interactor per screen doesn't really work a lot good in real life. We need to have, for example, when we initiate a payment, we need to make a server-side call, and then sometimes we have a loading view for it with a nice design and a nice loading indicator and a button to cancel. But sometimes we don't. Sometimes we just show loading indicator on wherever we are. So yeah, that's why we had to introduce some other type of the view that is not a UI view controller but a screenless presenter. And then the only thing that cannot be, the interactors can be reused as they are. And then we just need to have a different scene with different bindings for this case. So this worked pretty nice. The more maybe interesting case is a screen like this, when on one screen you have amount editing with validation, and then you can add message also with validation, and then you can authenticate with your PIN or with your biometry ID, and then you finally can make a backend call to confirm your payment. And then there is a design team that comes up with the 5 new features for the screen. So to put all of this in one interactor is, well, it's very hard. And here we had to come up with a solution on how interactors will communicate actually with each other. So we can implement it with the child view controllers that are either presented modally or just added as a child view controllers. But then when the message on this screen is added, how does this container, let's say, interactor knows about it? So the first approach was to put it in coordinator, and then coordinators, they grow very fast because of this delegate calls between different interactors. And what we are trying out now is to have some setup classes, functions that will bind signals from one interactor to signals of another interactor. So output signal of this message interactor to the input signal of this container one. And this is something we are still experimenting on. So how does it actually work in real life? I think this architecture is, I think the app that was initially written in Objective-C, and then migration to this architecture, I think, started maybe 1.5 years ago. So I work here for a year, and my experience is that it works pretty well. I mean, there is the downside. The biggest downside I see is that the learning curve for newcomers, especially if you don't know reactive programming, and I didn't know reactive programming when I joined, it's a bit hard to get on with all this structure. But once you get there, it works. And once you have some module working, there are not that many bugs there. I mean, there are usually no bugs in the interactors themselves, because you can easily test them, and usually we do. And the bugs are usually in the view, let's say. Yeah. So yeah, I think it's awesome. It's not yet bugs free, but we are getting there. And now, if all of this sounded familiar, that's probably because you read this blog post from February 2017 that gave an idea of this architecture. And well, it was modified here a bit by the people who adopted it, but yeah, if you want to read more, you can do it. So, thank you. Are there any questions? Yes.
Is it difficult to hire new people because you're using reactive functional frameworks? And is it difficult to maintain those frameworks, update, and keep up with them and new Swift changes?
No, I wouldn't say that it's difficult to hire new people because of reactive programming, because people, I think, are usually open to trying something new. In this view scene, in this scheme that I showed, we use reactive programming only in the scenes and the interactors, and it's only for like declaring what happens where. So for then helper classes, like let's say network client classes, they are written in usual way, not in reactive programming. Views are also not reactive, and coordinators are also not reactive. So we don't really have a purely functional reactive app, only some parts of it. To maintain it so far wasn't difficult because the framework that we use is good maintained, so it updates with the Swift update. Theoretically, it wouldn't kill the app to switch to another framework. I mean, of course, you need to go through all the classes and change them. But if we are now using Reactive Kit. If you would want to use RX Swift or I don't know something else, we need to basically change interactors and the scenes that are just declarations. I mean, not all the logic. Yes.
Can you tell us something? How did you actually decide to get to this architecture moving forward? I mean, it's just that somebody read an article said it's super cool, we have to do it, and I'm the boss, so we'll do it. Or how was the process to get there?
Well, it happened half a year before I joined, so I can only guess. But I know that the people who worked there at this time made some research on what they want to achieve. They wanted to do some Viper, and they didn't really like Viper because there is a lot of boilerplate code. There are a lot of these protocols, and it's a bit hard to switch between modules. So they were looking for something more pragmatic, and then I guess they came across this article and decided to try it. But this is my speculation. I don't really know how it really happened.
You don't know if they kind of dumped on the team and just said, okay, well,
the team is now 4 people. So back then it was maybe 2 or 3 people. So it was easy. Yes.
What approach do you use for UI building? Do you use interface builder, or do you construct all the UI from code, or maybe some DSL?
We don't use interface builder now. Well, almost don't use. We used to have a lot of storyboards. This architecture doesn't really work very well with storyboards because we want to control how the views are presented and inject all the dependencies we want. We could use interface builder just as zip files for the views. We now don't do it. Well, there are people who would like to use them in our team, so maybe we will. We don't do it because when the team was 3 people and none of us liked storyboards. It's very easy to decide when you're a small team.
So now it's mostly the code.
It is mostly the code, yes. Yeah, we use some frameworks also for constraints, so it's not that difficult. Yes. Yes.
Doesn't it feel strange? Or to me, it feels strange. If you want to add some functionality, it hits, you touch a lot of frameworks. For instance, if you want to add one screen, you have to change all these different frameworks. It would feel more natural to me to have one framework for new functionality, maybe.
Could be. It is. They are all they're all in the same project. So you're basically just switching between the groups in the project. So that's why it doesn't feel weird. But indeed, the compilation time is sometimes dramatic.
Well, for instance, if you want to add advertisement to it,
yeah,
I would suspect, well, you can just add a module for advertisement, and you can take it away also if you don't want it anymore.
Yeah.
Or if you want to add a different country, you can add a different module.
Yeah.
Or if you want to do different networking, you can add a different framework. But now it's in different frameworks. It feels like it's all over the place.
Well, indeed, it depends. If you want to add a new network client, you will just add it inside of the one framework and then just expose it. I mean, use the same protocol probably. If you want to add a new screen, yes, you'll need to modify something in the views, modify something in the scenes and in the interactors. It doesn't really feel, you don't really notice it because they're in the same project. So if you don't know, yeah. But yeah, there will be 3 files in different places.
Can I add something to that?
Yes,
Because
please.
we've been thinking about this approach. There is some conversation going on. But the good thing about this architecture is that if you need to rearrange your code to use a different framework architecture, it's very well divided. So it's just a matter of creating the target and assigning the files, and you package a feature with all the files you need. So in the event, we will decide to change to a framework per feature approach, like advertising or whatever, to be very easy to just rearrange the file into targets. And they should accept few refactoring, maybe work out just fine. That's what we hope.
Well, I like the approach that things are isolated, so you cannot touch them from the outside, even though it's an extension on it. But that makes sense, and you will lose that again if you do that.
Well, the thing is, now the target arrangement enforce this approach. But of course you can have the same if you use file private and private modifier. So of course we will need to change that a little bit, but it's doable. So you just need to declare things differently.
Right.
In the end, when you have a framework feature, you need to expose, so counting your public methods, counting your public variables, it's way easier. So in a way, you can make private what you don't want to expose, make sure it's public to fulfill your protocols, and and you change the modifier a little bit. Yes, you're right.
Yeah, you can also use the testing code in order to define your interfaces. How you want to define the interfaces, for example, when you you move this code into your framework, embed framework, or whatever it is, and then you define with the testing, you start defining what is it exactly that you're going to expose, what are the inputs and what are the outputs you expect, and that's it.
We think it's a good idea. We can maybe adopt some of that.
I tell you.
Yeah, no. I think we can take some ideas. That's why we're talking about
Yeah,
this.
that's why we have this. Yes.
How big are your coordinators?
It depends.
It should be a mess.
No, because we split them.
Because if they're keeping the logic for what? For part of the app, whole app? How do you?
No, I mean, let me try to control this thing. For example, this screen. For example, this tool, authentication coordinator. This whole screen is a payment coordinator, and then it's only the screen. I mean, if it becomes big, or if it's reused somewhere else, we split it. We have a few that are really big, but they are legacy code already, and they are planned to be refactored.
So your coordinator is handling at least 4 interactors, right?
Yes, but what it does, it creates them. It just creates them and presents them. It doesn't have logic. All the validation calls, they are all in it.
I mean, this is a sequence. This is a flow.
Yes, this flow is in the coordinator. Yes, so it is in coordinator. So what coordinator does? It creates this screen and presents it. Mm-hmm. Then it gets a delegate. Then it has a delegate method for show message composer, something like this. And then it will create the screen and present it. And then it will also know when to close the screen with a message or without. But that's not a lot of code. I mean, it's like 2 methods. Mm-hmm. So we don't. You can have them big, but we try to split them.
I wanted to go back to the interactor example. I think that was very clear.
Interactor example.
Yeah. Because
this one.
Yeah, because part of the logic you're mentioning, maybe we put it the interactor. So what happened when the user press load contacts? Mm-hmm. It's we fetch contact, etc. So this logic is in the interactor. doesn't pollute the coordinator.
Yeah.
Coordinator is
Coordinator
merely,
doesn't know about the logic also. Coordinator only knows that when it gets show message composer, it should show message composer. Yes.
So basically, the biggest code is in your interactor. There you have all the different
They are
logics.
not also
There
big
you plug all the, for
because
example,
they
the
only have
API
this.
stuff.
Like fetch contact is somewhere else in the helper classes. Yes.
I'm not entirely sure who is responsible for transferring data between the scenes. How do you transfer actually from I don't know the pin? How does it work?
So
For
this
example,
is
do you enter the message on the second screen there?
yeah. So this
or-
is what I was talking about. Our first approach was to put it in coordinator, and then indeed they started to grow. So we didn't like it, and now we try to bind the input and output signals of different interactors directly, and we will see how
so
it works.
the interactors know actually the interactor
They
of
well
the
we
second
use
screen knows of the-
well we use protocols, but
No, but I mean, that's the way
but
you-
that's
okay.
the way. Yes.
Thanks.
Yeah, imagine if you have to go back, you have
How's
to
unit
handle that
testing?
shit.
Yeah.
Sorry.
So how's unit testing going?
For the interactors, very
Are
good.
you writing unit tests? Are you-
Yes, we have, well, it's mandatory to have unit tests for all the interactors, for all the flows that we have there. So for different, for different flows, for different cases that you can foresee, we have unit tests. We don't test scenes, we don't test views, also coordinators we don't test. So only end-to-end tests and interactor tests
And how do you do the end-to-end?
with the UI tests. Yes,
XCUI?
yes.
Yeah, also I'd say using reactive make it very easy when somebody does something. For example, add a signal, happened to me recently. I added a signal and Maria spotted it. She told me, you didn't write a unit test for that signal. It's very easy to spot what you don't test with
Yeah.
signals. Sorry, Maria, for that.
Yes.
You showed one slide where
Yes.
which component knows about the other components. Which components does the this one? Which components does the coordinators know about?
All of them, basically,
All of them.
because they.
So it will be pretty much a next level compared to the.
Well,
scene,
I'm
right?
not sure. I think that the up target and coordinators are just in the up target. I think it should link to all of the frameworks.
Okay.
Yeah, they do. Okay.
What are your reasons that you chose for a framework-oriented way?
I mean, again, it was half a year before I joined, so I'm just speculating that it was to enforce this architecture. It was also one of the ideas in that blog post, so maybe people who chose for it decided to try it all. Well, my experience is that it works. I mean, it really prevents you from using things you are not supposed to use.
In this architecture, who is responsible for spawning a new screen to build all the components that scene, view, interact with?
I don't have a code sample for coordinator, but what coordinator does, it creates an interactor with all the dependencies injected, and then it calls this create scene method, and then create scene returns a view controller, and then coordinator just takes this view controller and adds it to the view hierarchy somewhere, how it needs to model it or in the navigation stack.
So coordinator pretty much should know everything about the screens that it manages, the ways to build them.
Yes.
How do coordinators work with each other? So if I have a flow and I have to start a different flow that's controlled by a different coordinator,
It creates a child coordinator.
and then it's, the child coordinator should respond to a listener interface that is done, and then.
But if needed with the delegates, yes.
And all of these are responsibilities of coordinator.
What, sorry?
All of these are responsibilities of a coordinator. So
Well, coordinator it just basically creates a view controller and adds it to the view hierarchy. And then when it gets some other, one of the delegate calls, they all can be narrowed down to either hiding the presented view controller or to showing a new one. That's all coordinator does.
But it's also responsible for managing child coordinators. Like not only the view controllers, but if it has to spawn a whole new flow, then it
Yes, it also starts new. Well, yes, it starts new flows also. In the app, how it is done now, there can only be one child coordinator, I think, per coordinator. I'm not entirely sure. Maybe not. Yes.
Any more questions? It's time for beer or cola.
Yes.